Round 6. Real-time shuttling. CPU shuttling for real-time operating systems involves special issues. In general, we can distinguish between soft real-time systems and a hard real-time system. Hard real-time systems have strict requirements. A task must be serviced by its deadline. Service after the deadline has expired is the same as no service at all. And the hard real-time system are composed of special purpose software running on hardware dedicated to their critical process and lack the full functionality of modern operating systems. As for soft real-time system, provides no guarantee to when a critical real-time process will be scheduled. The guarantee only that the process will be given preference over non-critical process. Consider the event-driven nature of a real-time system. The system is typically waiting for an event in real time to occur. So when an event occurs, the system must respond to and service it as quickly as possible. We refer to event latency as the amount of time that elapses from when an event occurs to when it is serviced. Two types of latencies affect the performance of a real-time systems. First, interrupt latency. 2. Dispatch latency. Interrupt latency refers to the period of time from the arrival of an interrupt at the CPU to the start of routine that services the interrupt. When an interrupt occurs, so like this picture, we see this interrupt processing until actually refers to the interrupt latency. Okay. When an interrupt occurs, here an event happens, we say interrupt occurs. The operating system must first complete instruction it is executing and determine the type of interrupt that occurred. It must then save the state of current process before servicing the interrupt using the specific interrupt service routine. The total time required to perform these tasks is the interrupt latency. So here, interrupt processing. After that, we enter dispatch latency. As for dispatch latency, we can see it is composed of two parts. One is conflict and one is dispatch. About the conflict phase of dispatch latency has two components. One is preemption of any process running in the kernel. Second, release by low priority processes of resources needed by a high priority processes. So after conflicts phase, we enter dispatch latency. That means the CPU has to dispatch That means the system has dispatched the CPU to the real-time event and to real-time process begin to execution. Then after a while, the system can respond to the real-time event. So this is response interval. It composed of two parts: interrupt processing and dispatch latency.